Hello, algebra students. Mr. Lawrence here, and I'm having lots of technical difficulties today. So I'm going to apologize in advance. I'm going to do these problems for you. We're solving, finding the nth term using input-output tables, but my airliner's not working, so I'm writing with the mouse. So bear with me, make sure you're listening carefully so that if you can't read a number, you can tell what it is. You should be able to do it. Hopefully I can get the problem fixed. But anyway, and it looks like I'm stuck writing in purple. Looks like everything, oh, that's coming out green. Okay, never mind then. All right, so let's see here. Finding the nth term, right? And remember, over the weekend and Monday in class, we took a series of numbers like -11, -4, 15, and 52, and 113, and we put them in an input-output table. And then we noticed, hey, I'm adding 7, and here I'm adding 11. Oh, no, not 11, excuse me. That's much more than 11, isn't it? Okay, let's see, that would be 19. Yeah, silly me. Okay, plus 19. Sorry, I meant that to be red. And let's see, what do we got there? 37, I think? Yeah, looks like 37 to me. Okay. Let me see, 40 and 13, is that 61? It sure is. By the way, if you're wondering how quickly I subtracted 113 and 52, okay, I thought about how far 52 is from 0. Well, it's 48 away from, oh, not from 0, excuse me, from 100. And then 113 is 100 is 13 away from 0 on the other side, right? And I added those two together. Okay, 61. So, you think about numbers differently, and sometimes it's a lot easier instead of doing 113 minus 52, which is a good method, it works. But if I think, hey, 52 is 48 numbers away from 100, 113 is 13 numbers away on the other side, the subtraction, the difference must be 61. Okay, now since I didn't get a match here, I go down to my second level, and I go with, what is that? Oh, now I have a mental blank, 12, right? And then that'll be plus 18, right? Okay, and then I believe 24. Okay, still didn't get a match, so I go down to my third level. And when I did that, I get a plus 6 and a plus 6. Okay, so it's clear that on my third level, the 6 is going to repeat forever. So I know my answer is something like n to the third power, right? Now I do my little comparison line, and I don't ever want you to erase anything. I might erase something so you can see it more clearly, but don't erase your work. Okay, so I'm going to cube 1, 2, 3, etc. and see what I get. So I get 1, 8, 27, 64, and 125. Well, how can I turn positive 1 into negative 11? Well, I can subtract 12, can't I? And now I turn 8 into negative 4. I must be subtracting 12. And I'll check one more, just so I'm not getting fooled. And I must do 125 minus 12 to get 113. So my formula becomes n to the third power minus 12. Now to figure out the 80th term, I'm going to have to raise 80 to the third power. Well, let me see. I think 8 to the third power off the top of my head is 512. So 80 to the third power would be, well, 512 and then 3 zeros, because I'd have to multiply each of those 8s that I cubed by 10, 10, 10, and 10. And then I have to take away 12 from that. Okay, so it looks like I'm going to have 511,988. Doesn't look like eights very much. Let me do that. That looks worse. Anyway, it's 511,988. Sorry about that. I wish my airliner were working. I'm gonna cry. I'll try again. I guess I could just type it. That would work. Okay, so that's the 80th term right there, right? Okay, now today we're actually going to investigate patterns that are a little bit different. I'll put that there even though it doesn't fit. And we're going to come down here to this pattern. So hopefully you make an input-output table. Now, because my airliners aren't working, I made the input-output table ahead of time. Okay, and I'm going to look in here, and I'm going to start off just like, before. I'm going to do, what was that, +2, finding the first differences. So +4, +8, okay, and there's a +16. Do you notice something? We're getting the same sequence of numbers as the purple ones, 2, 4, 8, 16. Now somebody's going, but there's no 32. Well, there would be if I had a sixth term. I don't have a sixth term in my data. And I bet the next one would be 64, and the next one would be 128, and 256, and 512, and so on, so on, so on, so on. All right. Um, if I go down and find the second difference, I'm going to be wasting my time. Because look, I'm going to get 2, I'm going to get 4, I'm going to get 8, and this is going to go forever and ever and ever. And I will never get it to repeat the same number. It'll never do it. So, oops, erased too much there. What I do know is, check this out. Can't I turn 2 into 4 by multiplying by 2? And 4 into 8 by multiplying by 2? And multiplying by 2? So since my differences are all products of the same number, I'm going to take that number, 2, and I'm going to raise it to the power n. I can prove it to you another way. Can't I think about 2 as 2 to the first power? And then 4 could be thought of as 2 to the second power. And 8 would be 2 to the third, right? And then 16 is 2 to the fourth, and 15 is 2 to the fifth. What would this one be? Well, wouldn't it be 2 to the power n, right? Now, I do my comparison line. I'll tell you though, you already know the answer for the nth term. So here's my comparison line. Hold on, let me keep that there. Okay, do it like this. And if I fill in, 1, 4, 8, 16, you can see the comparison line matches the purple line, the f of x line, the output line, very simply. So I don't need to do anything. My answer is 2 to the power n. Okay, now to do the 80th one, that is going to be one big puppy. That's going to be a large number into scientific notation. 2 to the 80th is going to be 1.21, and that's rounded, of course, times 10 to the 24th power. 1.21 times 10 to the 24th power. A very, very large number. A larger number than you even know how to read. Yeah, it's humongous. Okay, so let's go down here and let's try this one. I want you to see if you can do it. All right. Go ahead and pause the video. Go ahead and find the first differences. And then when you're ready, unpause the video. Okay, I'm back. Mr. Lawrence is very happy because I think my airliner is working. I think it was just a matter of a battery. So anyway, all right, let's see here. First differences, what do I have? +2, +4, +8, +16. And look, it's doubling. It's times 2 every time, isn't it? So even though it didn't quite look it, it's still some type of 2 to the power of n. So I'm going to go ahead 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 16, and 25. Oop, is there a mistake here? Hold on a second. Yep, I have a silly mistake right here. 2 to the fifth power, I've been teaching middle schoolers too long, is 32, not 25. Yeah, sorry about that. Okay, all right, now this looks a lot better. How do I turn 32 into 27? Well, I take away 5. 16 to 11, I take away 5. How do I turn 4 into negative 1? I take away 5. So for n, I'm going to do 2 to the power n minus 5. Okay, now when I get my answer for the 80th one, maybe 80 was a poor choice. I'm not going to use 80. I'm going to use, say, I'll use 10 because this is a big number. All right, so I'm going to do 2 to the 10th power, which might be 1024 if I remember right. Oops, hold on a second. 2 to the 10th power, yes, 1024. And then I take away 5, so my answer for the 10th one is going to be 1019. And there you go. All right. Well, I know that this is going to be a big one, so I'm going to change it to the 10th. Okay. Same drill here. Go ahead and pause the video. See if you can figure out what's going on with this one. All right. If you're ready to see my solution, it's what? Plus 20, plus 100, plus 500. And, ooh, is that going to be 2,500? I think it is. Wow. Now, what do I notice right off the bat? Hey, it's times 5 times 5 times 5. So in this case, my nth term is going to be 5 to the power n. I'll make my little comparison line. And 5 to the first, 5 to the second, 5 to the third, 5 to the fourth, and 5 to the fifth. Oops, silly me. Okay, and then I'm going to compare up. How do I turn 5 into 6? Well, I add 1. 25 to 26, I add 1. Should always compare 3 times. If you compare once, you'll be right 50 to 60% of the time. If you compare twice, you'll be right about 90% of the time. If you compare 3, you'll be right almost 100% of the time. There can be some weird anomalies that happen. So make sure you compare at least 3. All right, so looks like my 5 got erased there accidentally. So I have a 5 to the power of n plus 1. Now this is going to be big. To get this one, I'm going to do 5 to the 10th power, and then I'm going to add 1 to it. So I do have a calculator sitting here by me, so I'm going to go 5 to the 10th power, and then I'm going to add 1, and that's a pretty big number. Fortunately, it didn't go into scientific notation, but we got 9765626, and there you go. All right, those are the examples. Just a quick review that when the first differences match, it's linear, right? So if we had plus 4, plus 4, plus 4, we would have 4n, right? When the second differences match, it's quadratic. And it'll always look like this. On the second level, it'll always be plus 2. Okay? And so you'll have some type of x squared. You won't put the plus 2 into the formula for n. Okay, if the third differences match, it's cubic, and it'll always be plus 6 on the third level. We won't use the 6 specifically, but it'll be x cubed, and then we might have to adjust it. By the way, if the fourth differences match, it would be quartic, and I think it's plus 24 every time. We won't see too many of those, but it could happen. All right, and then when the differences, ooh, that looks ugly. Let me get rid of that. When the differences are multiples or are being are being multiplied, uh, have a constant factor. Like, let's see here. Let's go. 815. I'm sorry. Pardon me, losing my voice. Like times 7 every time. Times 7 every time. Okay. If you find that, it's going to be 7 to the power of n. Okay. And those are called exponential. I think I forgot to mention that. That is called exponential. So today what we actually did was mostly exponential functions. All right. I think that is the end of our video. I will sign off. Good night, everybody.